So today we are discussing about BGP, Border Gateway Protocol. Now, what is the use of Border Gateway Protocol and where do we use it? What is the use of BGP? See, if you have your autonomous system, BGP will be more often used by your service providers. So assuming that these are your service providers, like British Telecom, Sprint and all these are your service provider. This is one service provider autonomous system and this is, you can say, another. So autonomous system numbers can be from 1 to 65535, and in there is a range that is reserved. You can say 1 to 64512. You can use these numbers. Rest all the numbers are used for private autonomous usage, like public AS and private AS. So this is your public ASs, and after that till 65535 is your private autonomous system. Now assume that this is you, this is us, and when will we use BGP? If you have now this kind of an environment, only one is called a single homed environment. Means you have only one ISP. If you have two ISPs, then it is called a dual homed environment. Means a single homing, single homed or dual homed, single homed or multi homed, you can say multi-homed environment. Now, if you have only one route going to only one ISP, assuming that this is not present, you do not require BGP because it is only one ISP. This is your British Telecom ISP, and we will not use BGP when it is like this, because you can use a static route or a default route going to this ISP. So we won't use BGP in there. If you have an environment like this, you can say you will use BGP in a different environment. Now BGP is used to connect multiple autonomous systems. This is one whole ISP. This autonomous system will be connected to the another autonomous system on the internet, and BGP is a protocol that works on the internet. So if you see which protocol are we which we have been understanding is, this is your office, this is another office, this is another office, right? You connect your IGPs. In here we used to have interior gateway protocols, but now this is inside your office. You can say this was inside your office, but for you to connect ISPs to ISP, you will use border gateway protocol. So out on the internet you will have border gateway protocol. So BGP is an application layer protocol. It's like an application because it uses TCP port number 179. So it is going to require basic layer 3 connectivity, you can say. So if there is a router over here, this is a router over here, and this is a router over here, how does your 3-way handshake work? SYN, ACK and ACK. So if I say I want to send a SYN packet from here, BGP will send a SYN packet from a random source, so 10001, and it will be for the destination of port number 179. And when this guy receives it, so if this synchronization packet is sent by this to this guy, he will send a reply. So I send him a synchronization packet if he is running BGP. Now understand this, these are two separate autonomous systems. And if the other device runs BGP, then he will send us a SYN ACK back. These are TCP flags inside your communication, you can say. So as of now, this guy will send a reply from his source port number 179 to my destination. Normal TCP communication that happens to 10001, for example. We'll see all this in the packets. Let us see how will you connect your BGP over here. See, you will have two routers like this in your another autonomous system. So these can be your edge devices connected on my edge. Internally, I can have multiple devices also. So if I say I have a connectivity like this, Control V, if I say I am connecting from one autonomous system to another autonomous system, this type of connection is called your external BGP, ebgp. And if you say I have multiple routers inside this one in one AS, see, internally If you have a big organization, you can also run BGP over here. So you can run BGP in this kind of environment, no worries. If you have a big company, you can run BGP. And in here, if you are running BGP internally, it is your iBGP. So if you have two types of BGP, you will have two types of administrative distance, 20 and 200, two ADs also. Now BGP is a path vector routing protocol. It uses something called attributes. Attributes, these attributes you can say are weight, local preference, you have your origin code, you have AS path, you have MED. These are attributes, and for us to decide the best path, we will use these attributes. So weight is Cisco's proprietary term, so you won't see weight on the other devices. So you'll start from local preference, origin, metric, and all. Now there are two types of attributes. One is mandatory and one is discretionary, but it's okay. For us to understand the very basic of BGP, we just need to know that there are attributes, and while I send a route out, I might add some attributes and I might not add up some attributes. For example, this AS path, you can say it is the loop prevention mechanism. AS path means autonomous system path. For example, if I say, if in here I had one more autonomous system over here, one more autonomous system, and I had a router inside this one, and I connect it like this to this one. Now this router over here advertises a route. For example, he advertises 2.2.2.2. While advertising this route, this router will send this route by saying that this route originated. So this route should look like 2.2.2.2. This originated from the autonomous system 200. This is how it will advertise it to him. So I am router 2, I am advertising 2.2.2.2, saying that this has crossed my autonomous system. So my AS path is, you can say, prepended on this one. While router 1 advertises this route to the other guy, he will say 2.2.2.2 is coming from 100 and 200 and from there. So you will see that a route that passes one autonomous system, he will send out. So you can say this is a mandatory attribute. This, if I tell it to you, I will send it along with the update. So like that, there are some attributes that are not mandatory, that are for internal purposes. Now, if this same route, he advertises him, we are ISPs, we will have multiple connections. So if this guy advertises, he says, I know about 2.2.2.2, that is coming from my AS 300, 200 and 100, then it is originated, you can say. So this was your 300, for example, autonomous system. So this router, the receiving router over here, he will come to know that I am inside that, I am the transit path for this route, means there can be a loop. This route went via my autonomous system. This goes from me, this goes to 300. Sorry, yeah, this goes from me, this is myself. So if someone tells you that he knows our route and you are in between the autonomous system, this is technically wrong what I wrote. Yeah, 300, 100, 200 it should be. So it's okay. So 300, this is 100 and this is 200. So this router understands that this route has been originated by me and I am in the autonomous system path. So I told him about this route and he told him and he is telling it to me back. So I know that this is a loop prevention mechanism. So let us have a very basic implementation of BGP. Let us start a small process. Here I will give basic IP addresses 10.0.12.1 and 10.0.12.2 over here. And we will have ebgp because we are in separate autonomous systems. And understand that one router can be a part of only one autonomous systems. Let us see router 1 and router 2. So basic IP address configuration, we will have configure terminal, interface fast ethernet 0/0, IP address 10.0.12.1, 255.255.255.0 and no shut. Basic parameters on router 1. And then I will also create two loopbacks just for me to advertise later on. So I'll say interface loopback 1 IP address 10, I'll say 1.1.1.1 255.255.255.0 and exit interface loopback to IP address 192.168.1.1 255.255.255.0. No shut is not required. And let's say exit. Let's copy this basic configuration. Let's say Control A, Control C, and let's paste the basic config on router 1. So router 1 has an IP address 10.0.12.1. It is the 10th network between 12 and it is the first router, you can see. And the other side, I will simply use nothing here. I'll simply use a basic IP address 10.0.12.2. Nothing on the other side. So let's copy this and let's paste on router 2. And let's see whether our neighbor is reachable. Should always have connectivity ping 10.0.12.1. If I am pinging my neighbor, we should have successful basic communication. But now, how do you run basic BGP? For running border gateway protocol, you have to say router BGP autonomous system number over here. Router BGP here. BGP has unicast neighborship, means you have to specify the neighbor manually. You have to say neighbor 10.0.12.2 remote autonomous system is 200. So you have to specify your neighbor and his autonomous system, and by seeing this your router compares, oh, this guy is in another autonomous system, means this is ebgp neighborship. If you say 100 over here, means it becomes ibgp. So let us copy this. Let's say router bgp 100 and my neighbor is over here. Let us say router bgp 100 and neighbor over here. Now if you can debug the packets over here, for example debug ip packet detail or debug ip bgp, if you can see what is he doing. Now BGP is very slow in terms of communication, you can say. With the keep alive timer is 60 seconds, 1 minute, and the whole timer is like 180 seconds. So it's very slow in here because this guy is not running BGP. He will not give him, you see over here, the other guy has a source of this and he is destined to 179. Now he is sending me a synchronization packet, but what will I send? I am not running BGP. I will give him an acknowledge reset. I send him a reset message saying that I don't run BGP, I don't have this port reachable, so please come after some time. See, after a few seconds, again and again he will start sending his synchronization. But we are not running BGP over here. We will send him an ACK reset. Same will keep on happening until and unless I am not running BGP over here. I will not open my port 179 over here. So he keeps on changing the port. So what we will do here is I will say router BGP 200 neighbor 10.0.12.1 remote autonomous system is 100. The moment I give this, the three-way handshake will start. Syn, ACK. See, it has open idle states, idle to active. He started looking for a neighbor. And then they will see, okay, what are the parameters? And then they should form their neighborship. But you have to be very patient when you are doing BGP, because BGP will take time to converge. So it's not like EIGRP, OSPF, within seconds it will converge. No, they will do all the job. And then finally, you will see such a lot of things. They will discuss the capabilities, route refreshing and all. See, open is sent, open sent and open confirmed. See, source 179, just remember this number, because if your firewall blocks this port number, BGP neighborship will not come up. So if you're working with firewalls and all, you need to provision these numbers, protocol numbers, port numbers and all. So if I say here, show IP BGP, I will just say undebug all, show IP BGP. In here, show IP BGP will tell you the routes received by the neighbor, but I am not advertising. I did not give the network command, so no networks have been advertised. So show IP BGP summary will tell you about the neighbor state. Show IP BGP summary tells you that this is the neighbor identifier, this is local autonomous system, it is 200. This is my neighbor's ID, version 4 BGP. His autonomous system is 100. Table version is 1. Here, if you see blank, it is good because blank means it is established. And let us say show IP BGP summary for neighbor, or you can say 10.0.12.1. This should show you show IP BGP summary. Let me check what is the command for here. Show IP BGP for neighbors 10.0.12.1. In here, it will give you a brief detail, you can, a huge detail you can say. See here, the BGP state is established. Show IP BGP neighbor. This is a command, show IP BGP neighbor 10.0.12.1 and the neighbor's IP address. So he will tell us, okay, it is the router ID and this is the state that is established. The keep alive timer is 60 seconds. Hold down timer is 180 seconds. And here open sent and open received is good. Both have sent and received. It will tell you a lot of details. For troubleshooting, if you know, then it's good, but it's a huge protocol. Now, forming eBGP neighborship was very simple. And now, because now this was directly connected. And understand one thing, eBGP neighbor will have a time to live value of 1. So if you want to form, now BGP allows us to, the next practical that we will see, we will form neighborship from the loopback to loopback because loopbacks are very stable. But in here, eBGP, this is directly connected route. So we know that it is having neighborship. Now what I will do is I will advertise a route over here. I have 2 loopbacks over here. The loopback number is 1.1.1.1. It is a /24 and 192.168.1.1. It is also a /24. Now the thing here to notice is that these 2 networks have a little difference because this is a class C network. It is a normal network, but this is a class A network that has been subnetted. Now for BGP to advertise a route, he will check the routing table. If the route is in the routing table, it is matching the network command, then only he will advertise this route from here to here. So how does this route look in the routing table? Now what we have to do is, we have to go on router 1 and we have to go in the BGP protocol. Process, you can say router BGP. Here I am in the AS100. By mistake, if I say 101, it will tell you that you cannot run 2 BGP autonomous systems on one router. So, okay, so router BGP 100. Here you will say network 1.1.1.0 and you will say network 192.168.1.0. Now, the thing is, BGP will see the routing table and he will see, okay, the network you say is this and network you say is this. How does this network appear in my routing table? Because it sees the routing table and it advertises from there, you can say. Now, this route is exactly the same as it is over here, but this is not exactly the same. Do show IP route. In here, it is 100024, but BGP will think that this is a /8. By default, like RIP, it will think that this is a /8, but here it is /24. So this /8 does not match the /24. He will not advertise this route. He will advertise this as it is because it is same in the routing table. Let's go on router 2 and examine. Show IP BGP will tell us that this is a valid route. Star means it is a valid route and this is a best route. So if I want to advertise some route to somebody else, I will see that is this a valid route? Is this a best route? So why did I receive only 1? And here, see the metric. Metric is multi-exit discriminator, actually that one. This is local preference. By default, it is 100. It is not seen over here. Weight also is by default 32,768. You can say the spanning tree weight, and autonomous system path is this one. So these are important attributes, and usually the initial decision is taken by these attributes only. No worries. So hardly it goes beyond the 5th attribute, you can say. Now, if you want to advertise this network, you have to be very specific about it. You have to say mask. 255.255.255.0. So this statement over here matches the routing table, and it says this is /24. Okay, so if you say this is a /24, do I see 1110/24? Yes. So I will advertise it to my neighbor. So anytime doing class less things, you have to be sure that you advertise it with a mask command. So let's go and see now. Is he advertising it now? Yeah, it is advertising it now. Why? Because he sees, okay, for me to advertise, I check, I have a /24 like this.